Okay. Let us continue with today's topic. So our discussion is on the concept of SAP HANA architecture. So till now we discussed about so many things like you understood what kind of licensing we come across, what kind of system landscapes you come across, and the deployment scenarios we discussed. Now let us get into the core concepts of your database administration, and that the first one is so you need to understand the basic simplified architecture of SAP HANA. So look at this. So if you look at this diagram, as is clearly stated here, that this is called a simplified architecture. So the reason why they use the term simplified architecture, so not only this, later on we are going to learn about the service level architectures also. So the different kind of services and all that. That's a little bit later stages. So that's why it's called simplified architecture. So try to understand this. So if you look at this, basically you can categorize it into three parts. The top layer we have something called external interfaces. So then here we have the request processing and execution control along with the storage in the memory. Then at the bottom we have this storage, persistent storage, or we also call it as disk storage. So first let us start from here, external interfaces. So what is the significance of those external interfaces? So as is clearly mentioned on the left side here, you can see that external interfaces will allow you to communicate with HANA. You will be able to communicate with HANA using these external interfaces. So that communication will be doing for different reasons, maybe to execute some queries, or you may want to perform some data loads, or maybe want to perform some admin activities. But it all depends what kind of tools we are using for that communication. Example, observe here, if you remember other day, I explained you about the landscape. When the customer want to use HANA as data mart, so I clearly explained the entire landscape. What you do there is you set up HANA database, then replicate the data from different sources into HANA database. Okay, so this customer landscape we have seen clearly there. And then once data is replicated into the HANA database, they build models on top of those tables, which generally you call them as cubes. and based on these cubes they go for reporting. So basically reporting reporting is done on these cubes, which technically we call them as models. So now look at this. What I'm doing is I'm going to MS Excel, Microsoft Excel. Excel can be considered as one of the reporting tool, non-SAP reporting tool, which they can run on HANA. Observe what I'm doing is I'm just connecting to the HANA database using one of the option here. So here you can see that there is HANA MDX provider. It's basically a driver. You know, how do you get these drivers? So you need to install that HANA client software, you'll get these drivers. So that's already there. So that's why I'm choosing this HANA MDX provider. MDX means multi-dimensional expression. Click on next and I'm providing our HANA database server details. So I provided some server details here. I'm connecting to the database. So it's connection okay. So when I connect, see what we are able to access here. So we are able to access the models, which are generally called cubes. Once they select those models, they build the reports. So this can be one reason, the reason why you are communicating with HANA, but that you are doing using a reporting tool. So in such cases, that external interface used by this database is MDX interface. That we can easily understand. Multi-dimensional expression, MDX interface. So generally that MDX interface is used in the case of reporting. But that may not be same always. Like look at this. I'm just selecting one model. So instantly a small report I'm able to build here. So this data is coming from your HANA database only. But there are so many other ways you can access the data from HANA database. That's not the only option you have. Say example, I'm going to HANA Studio. In this HANA Studio, I'm opening something called SQL console. In this console, I'm just simply writing a select statement. So here, if I'm executing this, here also, I'm sending a request, getting the data and display. But in this case, the interface used by the database is different. That's not MDX interface. It uses SQL interface. And similarly, someone want to work the HANA database level. At the operating system, the OS, Linux operating system directly. So here you can use something called HDB SQL. Here in this HDB SQL also you can write the select statement and you can get some output displayed there. So in all those cases, this SQL interface will be used by the database. And then similarly, someone may access this required information through browser also. Look at this. So here I'm going to browser some application I'm opening. This is called HANA Cockpit. So here also I can just execute some SQL and get some outputs. From here also I can send the request if I want. I can write the same statement here. Otherwise, just simply I can open the table and check the data. So what I'm doing is I'm trying to interact with the HANA database, communicate with HANA database, but there are different ways. So here in this cases, the web interface will be used. So that's what the purpose of these external interfaces is. External interfaces purpose is to communicate with HANA, and that communication you're performing to perform some activities. Maybe as I shown you now, it may be executing some queries, or you may want to perform data loads or any other activity. Different users connects to the database for different tasks they want to perform. Okay, now through those interfaces you communicate with HANA. Now you are sending a query, like I written SQL statement. I send a query and the query is executed and the results is displayed. So if all this has to happen, all that is happening in a fraction of seconds, but if you see internally, a lot of processing has been performed by this HANA database. So first of all, if you just remember, now when I went to Excel and I chosen the driver, it's asking you to provide the server details. So I entered some database server details along with the user ID password. So what happens whenever a user connects to the HANA database? Doesn't matter which user is connected to the HANA database. Doesn't matter which tool they are using. So irrespective of that, first of all, whenever a user connects to the HANA database, the first and foremost thing system does is it will create a session. See here, there is something called session management. Understand? Whenever a user connects to the HANA database, any user, doesn't matter whoever it is. When they connect to the HANA database, the first and foremost thing performed there is first a session will be created. Now within that session, that particular user can perform transactions. Within the session, the user performs transactions, different transactions. Even whatever I send now, the request, that's also transactional. That's why here you can see that transaction manager here. So what is a transaction? A transaction is basically a set of commands. You can say group of commands, set of commands. Okay, so a set of commands, you are trying to perform an activity, some task. So whenever you want to perform an activity in HANA database, the first thing system has to check is whether the user who is trying to perform that activity is authorized to perform that activity or not. Because every single activity done in the database must be checked for that. What checking for authorization. So that's why you also find authorization manager there. So once system checks for that, if that user is authorized to perform the task, then only it will proceed further for processing. Okay, now coming to the processing part, as I mentioned, transaction is nothing but set of commands. Now those commands has to be executed. But remember, those commands will not be executed directly. Those commands again are split up into something called threads. So those commands, when has to be executed, as I told you, first of all, they will be split into something called threads. The purpose of those commands splitting up into threads is mainly for parallel processing, because one of the most important functionality in HANA database is parallel processing to improve the performances. So it plays a huge role in improving performances. Okay, so now those threads will be processed. So if you see the physicality of it, now when you're speaking about the processing a thread, actually those threads are processed by something called logical CPU cores. Logical CPU cores. One thread will be processed by one logical CPU core. Understand these points. I'm giving you these things slowly so that you'll just try to grasp them. Each thread will be processed by one logical CPU core. I'm repeating this entire process. First, you connect to the database. Whenever you connect to the database, there is a session created. And then within the session, you'll be performing transactions. There's no limit on the number of transactions you can perform within a session. Transaction is nothing but set of commands. Using that set of commands, you're trying to perform a task. So each command again is split up into threads. And those threads are processed by logical CPU cores. One thread is processed by one logical CPU core, provided it's available at that point of time. If not available, as usual, they need to wait in the queue. So logical CPU core. Generally, there's small confusions in the people. What is this logical CPU cores? If you know a little bit about your hardware, generally when you find information about your system, you'll find some details. Generally, what happens, they'll give you some details like processor. What is the processor you have there? Something like this, generally. Say Intel Arc Core i3. This is one processor here. These are all normal general desktop processors, but these are all multi-core processors. These are generally multi-core processors. One more example I'll show you for processors. See here, another system I'll show you. So here you see this information about this hardware. Here you can see that CPU cores, what is showing? Showing the 8 CPUs. Basically, it's an octa-core processor. Generally, in your mobiles also, now you have that multi-core processors you are using already, quad-core, octa-core. So this is a 8-core processor. So now here is the thing. Suppose you take one system, one CPU. One single CPU may have one processor or multi-processors. Understand this. So basically we call them as processor sockets. So here if you observe this machine, there is only one processor socket there. Only one processor socket we have. Generally, when you go with high-end servers, there will be multiple sockets. Yeah, in sizing I'll show you, but just have a look at the diagram, how those machines looks like. Look at this appliance, HANA appliance model on it. Here what we can see is these two are two processors, this one and this one. This is one, here we have one socket, here one socket, so the fixed processors, there are two processors we have there. So in such cases, in those systems, there it will show you processor sockets are two. Cores per socket is 8. So here in this diagram we have cores per socket, we have 10. So if I have only one processor and if it's having 8 cores there, it's basically you end up with 8 cores there, physical CPU cores. And here in this example, you see two processor sockets we have. Each one is having 10 cores, so it's 2 into 10, 20 cores. Physical CPU cores, you call them as. So then comes the next concept called logical CPU core. Now, what is a logical CPU core? Mainly in the server processors, not in your desktop processors. In the server processors, you have a technology implemented called hyperthreading. Generally, server processors, there will be hyperthreading implemented there. See, these are all desktop processors where you don't have hyperthreading. See, hyperthreading inactive is saying. But in server processors, you'll have that hyperthreading active. So, because of that hyperthreading, for operating system, OS if you take operating system, each core means each core is just like one CPU. That will be visible to the operating system as two cores, means two processors, two CPUs there. It will be visible as two CPUs because of the hyperthreading technology. So you take your HANA appliances, any HANA appliance you take, because they're certified hardwares, all those processors will be with hyperthreading. So that server what I shown you just now here, you have 2 into 10, 20 physical CPU cores. But actually if you see logical CPU cores, 20 into 2, 40 logical CPU cores will be there in this. So that is important. That's logical CPU cores. Number is very, very important for our HANA database. Look at this. And this database, I'm running this database. I'll just give brief information about the hardware on which this database is running. These are all normal systems what I'm using. They are not certified appliances. I'm using AMD processors here. So look at this. If you see the CPU cores, this machine CPU cores is showing is 4. CPU threads is showing is 8. That's how for the database it's visible. Actually, here I don't have hyperthreading, but hyperthreading how it looks like, I'll show you exactly here. This is another certified appliance. This one is a Dell appliance.
Look at this in the Dell appliance, how it looks like. This is Dell certified one. So number of CPU cores you see 12, CPU threads you see 24. And the CPU threads exactly, that's what it will tell you how many logical CPU cores we have. So CPU threads is nothing but logical CPU cores. So 24 logical CPU cores we have here. Actually, those CPU cores are the ones which are responsible for processing of the threads. Okay, this is a Dell PowerEdge series systems. They are certified models. And you can see the CPU sockets also. In this particular system, you have two CPU sockets. Means there are two CPUs, each one of with 6 cores, physical cores. 6 into 2, 12, 12 physical CPU cores. And logical CPU cores is 12 into 2, 24. So each thread will be handled by one logical CPU core. So more logical CPU cores you have, more parallel processing, better performance. Okay, so that's what you need to understand. Okay, CPU cores will do the processing and the response will be given. But now coming to the processing part, when a command has to be executed, any command you take, a command has to be executed. Your database doesn't execute the commands directly. Now, if I send a command, it won't be executed directly by the database. Because if you look at this, when the request comes here for processing, here you can observe we have something called SQL optimizer. The responsibility of this SQL optimizer is whenever a command comes for execution, first of all, it has to prepare a plan of execution for that. Because there is an optimum way of executing the commands. It's not simply a command comes and execute it directly. It's just like you want to reach some destination, there may be different paths. You want to choose the right one. So there is an optimum way of executing those commands. So what these SQL optimizers will do is it will identify that optimum way of executing the command. That's what we call it as execution plan. So whenever a command has to be executed, first of all, system will prepare a plan of execution called execution plan. And that execution plan will be stored, it will be stored in the memory only. There is something called SQL plan cache. SQL plan cache. There in that SQL plan cache, these execution plans will be stored. Then once execution plan is prepared, according to the execution plan, processing will be done by respective processing engines. But the reason why these execution plans are stored in the SQL plan cache purpose is if someone try to execute the same command next time, it doesn't need to prepare the plan once again. Obviously, it can save the time, so which automatically improves the performance for you. So generally, whenever a command comes for execution, it won't directly prepare the plan. It will verify if the plan is already available for this command execution in the SQL plan cache. If it's already available, utilize that plan and execute it. If not, it will prepare the plan and then according to the plan it will execute. But whenever a plan is prepared, that will be stored in the SQL plan cache. So the difference I'll just show you with a small example. These are all just for understanding. Don't worry, you have to go a long way. You need to learn a lot of things in HANA database, then things will become easy for you. I'm just showing you all these SQL statements I'm writing and all this just for your understanding that architecture. These all you learn later on. You'll be having special topics on this, detailed topics. So I'm trying to write a slightly complex SQL statement. So this is the first time I'm executing this statement. Observe when I execute this first time. I think it's already successfully executed, but here server processing time, preparation time 9 milliseconds, 724 microseconds it is given. Keep an eye on that. 9 milliseconds, 724 microseconds. It's like this statement yes, I just used earlier. Nothing else, any other table. Nothing much difference you are able to find it because already these are all plans prepared. But generally what we can see is you can find a significant difference here in this. Usually very first time it will take around 20 to 30 milliseconds here. This one. This time definitely you can see the difference because the reason is first time, very first time. Who is executing, who executed that, we don't know that. But very first time when the statement is executed, there will be a preparation time because a plan has to be prepared and that plan has to be stored in something called SQL plan cache. And then next time when we are executing it will just fetch it from the plan cache instead of preparing those plans. So that way, generally you can see there is a difference in your total overall execution times. So here you can see that this is called plan cache. So here all the execution plans are saved. So that's a statement what I executed now. There's a plan prepared and all that plan is stored here. I can find any information I want. So here it will show you maximum time taken, minimum time taken for those executions, as well as the preparation times also. So there will be a difference clearly you can find out when you see the execution times, first time and the next times. That's why they'll give you maximum time, minimum time, and average execution times also, so that you'll have an understanding. So when it was prepared, when it was executed, and all. This is server time. Don't worry. We are using a different time zones there. That's why it's showing that Jan 25th. No other reasons. Minimum, maximum preparation times and all. And execution times also. Slight differences, very minute differences we have here, 62, 67. But generally when you have large volumes of data, definitely it makes a huge differences for you. And that drastically improves the performance. That's why always whenever a command goes for execution, first of all, system will prepare a plan of execution for that, which we call it as execution plan. Will be stored in the plan cache, and accordingly, the processing will be done by respective processing engines. But one thing, if you observe here, when we say according to the plan, executions will be performed. If you see, as far as storage is concerned here, storing the data in memory, the relational engines they are given here, these two. Storing the data in memory, column store and row store we have. But on top of this, if you see the processing engines, what they're given, on top of row store, they're given something called row store engine. But whereas on top of column store, they're given multiple processing engines. So here comes the confusion for most of the people. Why is it so? Why is that difference? Why we have only one processing engine on top of row store? And why we have multiple processing engines on top of column store? So when it comes to HANA database, the specialty you have when you if you compare with the normal RDBMS and other databases. Generally in RDBMS you take like anything like Oracle, SQL Server, DB2, any databases like that. So in RDBMS we store the data in the form of rows. Basically we call it as row store. Any RDBMS. But coming to HANA database, the specialty we have is when we have some tables, when you even if you create a table also, you can decide whether you want to have the table created as a row store table or column store. Meaning of that is in HANA database both options are available for you. Either your table can be a row store table or your table can be a column store table. So that you will decide. Whenever you try to create the table, automatically that option comes. See here, we have type, column store, row store. The table type is not a table, only these two, row store, column stores. So either the table can be a row store table or column store table. So remember that in HANA database, tables are of two types, row store tables and column store tables. But what you need to understand is the terms you need to understand. What you are saying, you are speaking about row store, column store. Meaning of that is you are speaking about storage of the data. The way you see the data is normal rows and columns only. Suppose this table you take, if you right click and I'm checking the data in this, look how data is visible to you. Data is visible just like rows and columns. But looking at the data on the right hand side, I cannot identify whether this table is a row store table or a column store table. So irrespective of that, the way the data is presented to you is same, because that rows and columns is just a logical representation of the data. So the reason why they use the terms row store or column store is the storage differs, the way the data is stored. So if I create the table as a row store table, the way the data is stored is different the way data is stored when I create this table as a column store. So that's why here you have both. The relational engine stores data in memory. Here we have both column store given, row store given. And look at this. So here I'll also will be able to identify what is that used memory for row store tables and column store tables separately. So that also will tell you that the row store, column store options. So column store is something new. It's not that column store is available only in HANA database. Actually, this feature was introduced in Sybase earlier, but it's used very effectively in HANA database, the column store. So if you want to understand why those processing engines are different on these row store tables and column store tables, if you remember the other day when I explained you about these landscape architectures, I clearly told you that once data is replicated into HANA, they don't do reporting on the tables directly. I told you that they build the models, which generally you call them as cubes, but not in HANA, because HANA is a database. Database doesn't have any object called cubes. So in HANA database also they build those models. But in HANA database, those models, they call them as information views. Instead of the term cubes, they call them as information views. Cube is a general term. But you want to be specific to HANA database, you call them as information views. So once data is replicated into HANA and stored in tables, on top of the tables, they create information views. Based on the information views only, they go for reporting. And that too, whenever they're creating those information views, which actually will be done by modeling consultants, they create different types of information views like this. They create information views like attribute views, analytic views, there is something called calculation views. Three types of information views they create for their analysis purpose. What analysis they want to do, why they create, that's their job. That you don't worry. But what you need to understand is when they create the models, which we call them as information views in HANA, So basically they create three types of information views: attribute views, analytic views, and calculation views. And these information views are allowed to be created only based on column store tables. Remember this statement, very important. Information views are allowed to be created only based on column store tables. So that's the reason why if you see on top of column store tables, they're given three processing engines. The purpose of this join engine is to process attribute views. OLAP engine is to process analytic views. Calculation engine is for processing calculation views. Three types of views are processed by three types of engines. Anyhow, you're not allowed to create these information views based on the row store tables. That's why we don't need them on top of row store. Row store normal SQL statements I can write which can be processed by row store engine. So that's why the difference you have. But then comes the question generally, why? Why they restrict creation of these information views only based on the column store tables? So that question, if you want to get an answer, you should understand first of all what is the difference between a row store and column store. As a row store is a old thing, why they came up with this column store concept? What is the specialty in that? What advantages you have? And that if you understand, then you can easily realize why they allow you to create or restrict you to create only the information used only on the column store tables. It's all about performance ultimately, but there are many other reasons. But that if you want to know, you need to do a comparison between column store and row store and understand the column store tables in a better way. Because that's a very significant concept in SAP HANA database. Very important, understanding that column store. Because all the application tables, they'll be storing them as column store tables only. All the application tables, your ERP tables, CRM tables, anything, any application data, customer, material, sales order, invoice, anything like that. All those tables will be column store tables. So that's what our discussion is going to be tomorrow. So we are going to dedicate half of the session exclusively for understanding the difference between row store and column store. And then automatically you'll realize why information views are allowed to be created on column store. And then another half of the session will continue with the discussion on understanding the disk storages also, why we need disk storages and all. Then it becomes easy for you. Overall complete understanding you'll get.